Hello students, welcome to the interesting chemistry where you will find a feeling of classroom teaching. If you want to enjoy a classroom teaching from your study room, then please watch my video of interesting chemistry. In my previous video I have made up some videos of the nomenclature of the organic compounds or the IUPAC system of the nomenclature and the redox reactions, in which I have made up so many videos of the oxidation number and the oxidation reduction and the balancing of the redox reactions. I mean to say balancing of the oxidation and reduction reaction in the acidic medium and both in acidic and the alkaline medium. So today's topic is the classification of the elements, or the genesis of the periodic table, or you can say the history of periodic table. I know it very well that the history of the classification of elements is not necessary for your examination point of view, but it's my duty to acknowledge with the genesis of the periodic table, because we have to study the modern periodic table and the electronic configuration of all the elements. So to relate the modern periodic table, you should know about the ancient periodic table or the previous periodic table, that is the Mendeleev law or the Mendeleev periodic table. So I want to relate the Mendeleev periodic table to the modern periodic table, because the modern periodic table is the form of the modern form of periodic, the Mendeleev periodic table. So I think it's my duty to acknowledge you with the history of element, the classification of elements. First of all, I will explain you that why do you need the classification of elements? Because in the previous and the ancient days, or in the ancient days, or in the primitive days of the chemistry, there were a few elements. In 18,000 there were only 30 elements that were elements were known. So we can study individually these elements, but as the number of elements increases, so it becomes very difficult to study individual elements and their physical and chemical properties and their innumerable compounds. So scientists thought about to find a systematic way to study these old elements, and some attempts were made by different scientists that are written on this blackboard. The first attempt was made that the elements can be classified. Elements can be. Here I want to give you an example. Suppose there are 200 students in the plus two, and all the teachers of the plus 2 and these students are sitting in a prayer ground. Can all the teacher teach you all students as a whole? Never possible. It is impossible. So we have divided you over the faculty, science faculty, arts faculty, and the commerce faculty. So there are 80 students in the science faculty, and all the teachers of the chemistry, physics, and Hindi, English will start teaching you combinedly. Can it possible to understand anything? It's impossible. So again, you are dividing the periods. First period is for Hindi, second. So it is this systematic classification of the students to teach them in the school. So that is why the periodic, your timetable, first period, second period, to ease out the problem of studying or the teaching in the classroom. In the same way, to understand about each individual element, we have to classify them. So as I told you, the first attempt was made that all elements were divided into metals and non-metals. In the ancient days, there are copper, iron, and lead. Such elements are called metals, and the oxygen, nitrogen are called non-metals. But after discovery of the carbon, sulfur, these are non-metalloid or the some metals. So, but it is for the preliminary knowledge. But second, then we decided then some scientists made some families, that alkali families, alkaline earth metal families, and halogen families, lithium, sodium, potassium, alkaline metals, barium, magnesium, calcium, strontium, barium are the alkaline earth metals, and fluorine, chlorine, bromine are the halogen family. But these are not helpful to study about the individual element or the individual. But after that, the Dobreiner here started. This is the Dobreiner. Dobreiner gave a law. Dobreiner found that there are some elements which have the similar properties. And he made a group of 3 elements that is called triad. Suppose there is a lithium. It is lithium 7 number. So lithium, sodium. You know sodium number is so lithium 7, 11, and lithium, sodium, potassium, that is 19. Lithium 3, and the atomic weight of the lithium is 7, potassium is 39, and the atomic weight of the sodium is 23. So here there is all the 3 elements have similar properties, have the alkaline properties. But here there is a trend in the lithium, sodium, and potassium. Sodium is more, lithium is less reactive than sodium, and sodium is less reactive than potassium. This is a trend, and all the 3 elements are alkaline. And besides that, there is a relation. The average of atomic weights of the first and the third. The average atomic weight of the first and the third element of a trial, 7 plus 39, average divided by 2, it means 23, is equal to the atomic weight of the middle element, second element. This is the second element. So here, this is the relationship between the sodium and potassium. Dobreiner told about that in a triad, the average atomic weight of the first and the third element is equal or probably equal, approximately equal to the middle member of that triad. So here, in this case, I can tell you so many examples that is chlorine, bromine, and iodine, and so calcium, strontium, barium. They are the examples of the triad. Now I am telling you the history of briefing the Newland octave rule. What is the Newland? Newland, there was a scientist who arranged all the elements in the increasing weight. all the elements were arranged in the form of the increasing weight. Suppose he found Newland octave rules. Newland found that the eighth element, the properties of the eighth element is equal to the first element. The properties of the eighth element is equal to the first element each. And in the same way, he arranged this lithium. I am giving you lithium, beryllium, boron, lithium 3, 4 and 5, 6 carbon, 7 nitrogen and nitrogen, then oxygen 8. 1, 2, 3, 4, 5, 6 lithium, beryllium, oxygen, then the fluorine 9. This is lithium, beryllium, boron. These are the 7. Now come to the sodium. This is sodium 11. This is the 8th element. So he put the sodium here. He placed sodium here under lithium. Because lithium and sodium have similar properties, then come magnesium, then boron, aluminium, carbon, sulfur, nitrogen, phosphorus, oxygen, carbon, sulfur, phosphor, oxygen, carbon, silicon, so not sulfur, silicon, oxygen, sulfur, and here chlorine 770. This is so the eighth element. This one is eighth element is similar to the element the eighth element is magnesium. From beryllium, the eighth element is magnesium. So the properties of magnesium is similar to the beryllium. In the same way, the properties of aluminium is similar to the boron. So he told us the octave law. Why did he call it octave law? Because as it is in music, sa, re, ga, ma, pa, dha, ni, and again sa. So from the octave of music, he related all the elements. So this is called the Newland law of octaves. It is also, but this octave law can explain up to 20 elements. Then this law was not accepted by the then scientists, but this law is very important the primitive state of this law was used by Mendeleev. So after Mendeleev, the Newland octave laws was recognized by the present scientists. So again, I am telling you about the Dobreiner law. Dobreiner studied about the physical properties of the elements, and he related the physical properties, the melting point, boiling point, and the atomic volume to the atomic weight of the elements. So he plotted a graph on the atomic weight and volume. He plotted, and the graph was one in this way, the graph and this way. Here this was the graph and so on. The form of the graph was this, and he found that the elements of the similar properties acquire the same place. Suppose this is lithium, the more active, lithium, sodium, potassium, rubidium, cesium, and there will be francium. This is the way the elements of the similar properties acquires the same position, location on this graph. This lithium is peak on the peak, the sodium is on the peak, and potassium, rubidium and cesium. Suppose here this is the helium, here it is helium. Neon is here, argon and krypton and xenon. These are the about Dobreiner. Now I am coming to the Mendeleev law. Mendeleev law or the Mendeleev periodic table. What is Mendeleev? I think that I have acknowledged you all the steps of the history of the classification of elements, all the genesis of the periodic classification. Now come to this Mendeleev law or the Mendeleev periodic table. Dobreiner, as I told you, Dobreiner and the Mendeleev were working simultaneously in the same period, but Mendeleev proposed a table. Mendeleev made a table that is called a Mendeleev periodic table, and on the basis of Mendeleev periodic law, Mendeleev law, Mendeleev told us, the law told us, what was the Mendeleev periodic law? Mendeleev told us the physical and chemical properties of the elements are the periodic function of their atomic weights. So please write it down, because this definition, we will change this definition for the modern periodic table. So I am relating the Mendeleev law and the law of modern periodic table. So again I am telling you, the physical and chemical properties of the elements are the periodic function of the atomic weights of their atomic weights. Again write it. The physical and chemical properties of the elements are the periodic function of their atomic weights. This is the Mendeleev periodic law. Now here a term is introduced, that is periodic law. What do you mean by the periodic? This term came from physics. In your physics, you have movement. This is the periodic. Suppose this is the pendulum, and this is the one portion, and this is the period. After a particular time, this pendulum will go and will repeat itself. After a particular time, after a definite time, this pendulum will acquire the same position from which it start to move. So this pendulum, in 1 second, it will go here and again come. This is the repetition. The position of the pendulum will be same. The location of the pendulum. This is this motion called the periodic motion. As our watch, it is after 12 hours they do the second, after 1 minute the hands, this second hand moves this, acquires the same place after 1 minute. This is also a periodic motion. So in this same way, how can you use this periodic after a particular number, as Newland told us, the eighth number? In the same way, Mendeleev used this same Newland's octave system, octave law, that the eighth element of each element is the properties of the eighth element are equal to the first element. the Newland octave law, that was so. By using the octave, Mendeleev made this here, and this one is the Mendeleev table. Mendeleev table is the most important part of the history of the classification of elements. He gave a law that as I have told you earlier, that the physical and chemical properties of the all elements are the periodic function of their atomic weights. And on behalf of this periodic law, he made a table that is called periodic table. In the periodic table, there are 7 horizontal rows. These rows are called horizontal rows. And again, these horizontal rows, these rows called period. The name was given to this horizontal row is period. And these are the columns, which are the vertical columns. And these vertical, the name given to the vertical column is groups. So here there are 7 periods. There are 7 periods. One first period. Suppose this is first period, second period, third period, fourth period, and fifth and sixth. In the same way, there are 7 groups: first, second, third, fourth, fifth, and sixth. And this is 7th group, and this is 8th, and total there are 9 groups. First to 7, and this is 8th, and this is 0. So there are in original periodic table of Mendeleev, there are 9 groups. After the 4th period, each 1 to 7 group, each group is divided into A and B. This groups up to 7th, this 4th period, first A and B. So these first 2 7 periods are divided into 14, which is the A and B. So here, and this 8th period has 3 columns. This has 3 columns. So this is 3 columns and this 0. So in this way, there are 14 columns. 7 are divided into A, B. So 7 into 2 is the 14 columns. This 8th group has 3 columns, and this 0 group has 1 column. So there are all these are the 14 plus 3 plus 1. There are 18. In this way, there are 18 groups in your modern periodic table. So if anybody asks you how can you write the 18 groups in the modern periodic table, so these are related to the Mendeleev periodic table, because there are 18 column in the Mendeleev periodic table. So in this was my mean. I want to relate this Mendeleev periodic table to the modern periodic table. Now how will he make the periodic table? So he arranged all the elements in the increasing order of their atomic weight, and then he found that the elements with similar properties occupies the same vertical column. Suppose here lithium, suppose here come lithium, then again the lithium will then come sodium and then potassium. The similar property here in this 18, this is beryllium, magnesium and calcium, etc. In this way, the elements with similar properties occupy the same vertical column. So in this way, in a group, the elements which occupy a group has the similar properties. This was about the Mendeleev table, and my purpose was to tell you about the Mendeleev table, to relate from where the 18 columns 18 columns have come to in the modern periodic table, and since there are 7 periods and 18 columns, and we will find. So in my next video I will tell you the modern periodic table. I hope that you have understood, and my motto behind to tell you the history of the classification of elements was that to relate this old history to the modern law of periodic table or the modern periodic table. That's about. So please like my video, share your video, the content. No, I think that this video is not so important for your examination point of view, but for the knowledge of chemistry. You should know, you should learn about the history of the classification of elements or the genesis of the periodic classification. So please, in the last, I hope that you will like this video, this will share with video. These videos are for those students who cannot afford the higher fees of the coaching centers or etc. Those are studying from, those are preparing for the IIT from their home. This video will be very helpful to those students. So please like it and share this and tell your friends about the videos of the interesting chemistry in which I have told you that I have made up of the IUPAC videos and about the redox reaction. So for today is all. That thank you very much.